Let's solve a set problem. We need to find the set C, where C is the set of all integers y such that y cubed is less than or equal to 27. To solve this, we'll use the listing method. This means we'll test different values of y to see which ones satisfy our condition. Let's start by making a table to evaluate positive integers. Let's start with y equals 0. 0 cubed equals 0, which is less than 27. So 0 is in our set. Next, 1 cubed equals 1, which is less than 27. So 1 is in our set. 2 cubed is 8, still less than 27. 3 cubed is 27, which equals 27. So it's in our set. But 4 cubed is 64, which is greater than 27. So 4 is not in our set. Now, let's check negative integers. Remember that when you cube a negative number, the result is negative. Negative 1 cubed is negative 1, which is less than 27. Negative 2 cubed is negative 8, still less than 27. Negative 3 cubed is negative 27, which is less than 27. And negative 4 cubed would be negative 64, which is also less than 27. In fact, all negative integers will work because their cubes will always be negative, which is less than 27. Therefore, our set C includes all integers less than 4. Let's visualize this on a number line. The blue dots represent the integers that are in our set C, and the red dot shows where the set stops at y equals 4. In set notation, we can write this as C equals the set of all integers y such that y is less than 4, or in interval notation, C equals the intersection of the integers with negative infinity to 3 closed on the right.